Here's the solution for day one. Use power-reducing formulas to write the expression in terms of the first power of cosine. We're starting with cosine to the fourth power. In the first step, we can write that as cosine of squared of x squared. Then we can apply the power-reducing formula to the cosine squared of x. That will create 1 plus cosine of 2x all over 2 squared. So inside the parentheses, this right here comes from using the power-reducing formula on the cosine squared. In the next step, I want to actually square what's inside the parentheses. But before I do that, I'm going to write it in its binomial form. That's 1/2 plus cosine of 2x all over 2, and that's what's being squared. The reason I'm doing that is this is a binomial squared, and we've done that all year long. So to square a binomial, you square the first term, that makes 1/4, and then you double the product of the two terms. So 1/2 times the 1/2 cosine 2x is 1/4 cosine 2x. When you double that, you're back to 1/2 cosine 2x. And then plus, and you square that last term. So that would make 1/4 cosine squared of 2x. Now we can apply the power-reducing formula again on this piece right here, on this cosine squared piece. So this will make 1/4 plus 1/2 cosine 2x plus 1/4, and then in parentheses, let's make our substitution for the cosine squared 2x, where we use the power-reducing formula. It's 1 plus cosine 4x all over 2. At this point, we have the cosine expressions to the first power, which is what we were asked to do. But we can simplify this up a little bit, make it a little more compact. So in the next step, let's distribute the 1/4 to what's in the parentheses over here. We'll have 1/4 plus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. And finally, I'm going to combine like terms, the constant term 1/4 and the constant term 1/8. Those can be added together. That makes 3/8. And then the plus 1/2 cosine 2x plus the 1/8 cosine 4x. So here is my final simplified answer. Next, question B. Find exact values for these different half angles by using the half angle formulas. And what we have to start with is that the sine of angle U is 5/13, and that angle U exists between pi over 2 and pi. This is quadrant 2. When you look at the half angle formulas, you'll notice that they involve cosine. And so we need to find the cosine of angle U. We can find it in two different ways. One is there's an identity, sine squared plus cosine squared equals 1. We could substitute the 5/13 in place of sine and then get an answer for cosine. Or we can pay attention to values for the x, y, and r. That's the way that I'm going to do this. So if sine of U is 5/13, that means that y is 5 and r is 13. And with the Pythagorean theorem, I can get that the x is either a 12 or a -12. Now we're told that angle U is in quadrant number 2. That means that x is a negative number. And so the cosine of U is equal to -12 over 13. Now that we know that value for cosine of U, let's get the three half angles we're asked for, starting with the sine of U over 2. The formula has a plus negative sign, but that's used a little bit differently than we have in the past. We're not writing plus and negative, meaning there's two different answers. What we're supposed to do is choose which one we need, based upon what quadrant the angle is in. If angle U is between pi over 2 and pi, which means it's in quadrant 2, when you find half of that angle, that would be in quadrant 1. The sign values of angles in quadrant 1 are positive, so I'm going to choose the positive sign. Then there's a square root. Inside the square root, it's 1 minus the cosine of u. And we had figured out that the cosine of u was negative 12 over 13. And then that's divided by 2 inside that square root. Now let's simplify. This will make the square root of 25 over 26. The negative negative makes a plus sign. The whole number 1 can be thought of as 13 thirteenths, and the 13 thirteenths can be added to the 12 thirteenths, making 25 thirteenths. When you divide by 2, that's 25 over 26. Now do square root. The square root of 25 is 5, and the square root of 26 is in the denominator. Now let's rationalize this. This is 5 square root of 26 all over 26. Next, let's get cosine of u over 2. The formula has the plus negative sign, meaning we're supposed to choose whether it's going to be positive or negative. We had already figured out that if angle u is in quadrant 2, then half of that angle would be in quadrant 1. Angles that are in quadrant 1 have positive cosine values. This time, it's 1 plus the cosine of u, all over 2. And now let's simplify this square root. Think of 1 as 13 thirteenths. When you add the negative 12 thirteenths, you get 1 13th. And 1 13th divided by 2 is 1 over 26. The square root of 1 makes 1, and the square root of 26 is in the bottom. Then rationalize. The square root of 26 all over 26. Finally, we have to get tangent of u over 2. There's actually two math formulas we can use on this, and it doesn't matter which you use. I'm going to use the first one. It's 1 minus the cosine of u divided by the sine of u. And now let's simplify. The negative negative makes a plus. This is 25 over 13. When you divide by 5 thirteenths, that's like timesing by 13 over 5. The 13s cross cancel, and the 25 over 5 makes 5.